So hello everyone, welcome back to another video. So today we are going to solve questions from 29th January shift 2 of JEE Mains Jan session 2025, and this was the paper which I have written for my JEE. So yeah, let's start the questions. Okay, the first question, okay, let me clear up the ink on the slide. First question says, okay, it initially gave us velocities for these three balls, and then if we wait sufficiently long enough for collisions to happen, these are the final velocities. This is the assertion, and they gave us some initial velocities, and after the collision they gave us some final velocities. And the reason they gave is, in an elastic collision between identical masses, two objects exchange their velocities. We know that this is correct, so the reason is true. Now let us check about the assertion. So let me make the velocities like this for each ball. As okay, they told that they are identical spheres, so we know that they'll just exchange velocities if they collide. So initially they gave velocities as 5, 2 and 4. Now we can see that ball A is the fastest among all, and so it's going to first collide with ball B. So once that collision happens, these two are going to exchange their velocities. So after the first collision, our velocities are going to become 2, 5 and 4. Now we can see that 2 is very slow. 2 is slower than 4 and 5. So our ball A is never going to catch up with these two ever. So the next collision which is going to happen is B colliding with C. After that collision, B and C are going to exchange their velocities. So then we get these as our velocities, 2, 4 and 5. And now we can see that 2 is smaller than 4 and 5. So ball A is never catching up with these two. And similarly, ball B is slower than ball C. So even ball B is never catching up with C. So now we can see that these balls are never going to meet again ever. So these we can say are the final velocities of the balls. So let us see what they gave in the assertion. They gave velocity of A as 4, B as 2 and C as 5. But that is wrong. We got A as 2 and B as 4. So we get that assertion is wrong, but the reason they gave is correct. So we get option 1 as correct. To the next question. Okay, they gave us the same lengths, but we are cutting them in two different ways. Initially the focal length of the whole thing is f, and we have cut it horizontally and vertically in each case, and then they are asking the ratio of focal lengths in each case. We know that even if we cut a length horizontally, we know if it's cut horizontally, we know that its focal length won't get affected at all. So the focal length of L1 is going to be f itself, the original f which they gave in the question. Now coming to L3 and L4, here we might have to do some calculations. So we have to use the lens maker's formula. So lens maker formula says that 1 by focal length of the lens is given by refractive index of the lens by refractive index of the medium minus 1 divided by the radius of curvature of the first surface minus the radius of curvature of the second surface. Here we have to take both radii of curvature according to sign convention. Only then we'll get the proper value of the power of the lens. This is nothing, 1 by f is nothing but power. We need to take sign convention. Alright, now let's apply it. So I'll do it in the next page. Let us take, if we cut it vertically, this is what we are going to have. So let's assume radius of curvature as r for this, and we know that radius of curvature of a flat surface is infinity, and assume mu is the refractive index of the material of the lens, and let's assume air as the surroundings. So we have 1 by f is equal to mu minus 1 times 1 by r1. r1 is just infinity, 1 by infinity minus, and here let me tell you how to take the sign convention. This is an easy trick which I use. So what I do is, we want the radius of curvature at this point, right? So what I do is, if you want to make a circle, which direction do you need to go? This way, right? The center of the circle is this way now. So I have assumed this as my positive x-axis. So because I am going this way to go towards the center of my circle, my radius of curvature is going to be negative. So therefore I need to take minus r over here as the radius of curvature. This is an easy trick which I use. Minus 1 by r. So we get that, let's assume this as f3 because L3 they said. 1 by f3 is equal to mu minus 1. 1 by infinity is just 0, and minus of minus is going to become plus into 1 by r. Alright, now let us do it for the original length. When you cut it into, okay, we have this as our L1, but we know that this and this are equivalent lengths. Optically speaking, the focal length is the same. So let us do it for this length. So they said it's symmetrical, so this curvature is r and the curvature is r over here. Now let me tell you how to apply sign convention on this side. So again, you go to the point about which you want the curvature. Now look at which direction do you need to travel to go towards the center of the circle. You go in this way. So as these are my coordinates, this is positive x and this is positive y. My radius of curvature on this side is positive, and as we have done in the previous lengths, on this side it's negative. So I get minus r over here. So let us apply the formula for this length. So we get 1 by f1, we'll assume, because L1 is equal to mu minus 1. This, the original, the first side has positive radius of curvature, so I'll write 1 by r, but the second side has negative, so minus 1 by r. Minus and minus will become plus, so you end up adding 1 by r and 1 by r. So you finally get 1 by f1 is equal to mu minus 1 into 2 by r. So but what do we have? We have, this can also be written as mu minus 1 into 1 by r into 2. But what do we have from the previous statement? Here we have that this thing is just 1 by f3. So what I'm going to do is, instead of division and all, we can just, where I have this part right over here, that's just 1 by f3. So I'll write this as 1 by f3, and we end up with 1 by f1 is equal to 1 by f3 into 2. So we get f1 by f3, which is the ratio they have asked in the question, is equal to 1 by 2, and that's the answer. Let's see if it's there in the options. And then yeah, option 2 is correct. The ratio of focal length of L1, that's f1 over here, and f3 here, it's 1 by 2. Now let's go to the next question. We should be very careful over here. An error which people generally tend to do is, the entity which we are solving for over here is 1 by f. People normally, they write 1 by f, but while division, a common error is people take this as f and do it. That is totally wrong. You get the reciprocal of the answer, and as always you will also have the reciprocal in the options. The reciprocal is also given here to confuse you, but always make sure. This is a very common error. Alright, next question. Two bodies A and B of equal masses are suspended from two massless springs of constant K1 and K2, and then they are oscillating vertically. We know that it will perform vertical SHM, and then they are asking the ratio of maximum velocity of A to maximum velocity of B. Okay, so what is the general equation of an SHM? The position is given by amplitude sine into omega t. Omega is the angular frequency. Now let me differentiate on both sides. So I get, okay, here let me take it as y because it's performing vertically, so I'll write it as y. So I get dy by dt is equal to A, and differentiation of sine omega t is, apply the chain rule over here because it's a complex function inside. Differentiation of the inside function is omega, and differentiation of sine omega t with respect to omega t is cos omega t. Cos omega t. And this dy by dt is nothing but the velocity of it, and they are asking the ratio of maximum velocities. So when will this ratio be maximum? When, here we can see that a omega is constant value. The only thing changing is the cos function, and the maximum value the cos can give here is 1. So V max is given by a omega. So this is the prerequisite we need for this question. Now let us solve. So V1 max by V2 max will be given by they have given that amplitudes are the same, so I'll just use A for both the cases. A omega 1 by A omega 2. So we'll end up with omega 1 by omega 2, which is the ratio of the maximum velocities. Now we need to find omega. So we know, what do we know? We know time period of a spring is 2 pi root mass by the spring constant. And what do we know? We also know that time period is nothing but 2 pi divided by omega. So we get 2 pi by omega is equal to root 2 pi root m by k. Now rearranging and cancelling 2 pi, we get omega is equal to root k by m. So alright, now we have gotten this question almost. So what do we need? We need omega 1 by omega 2. So omega 1 is root k1 by m. They are told even the masses are equal, so it's just m. And omega 2 is nothing but root k2 by m. Now dividing both of them, we get omega 1 by omega 2 is equal to root k1 by k2, as the masses cancel out. So therefore we are left with, which is the ratio of, which is the maximum velocity square ratio which they are asking in the question. Alright, so we get root k1 by k2 as the answer to this question, and option 2 I'd say is correct. Alright, again a very common error over here is people always, they write the formula of the time period and directly do the ratios with that, which again, and we end up with the reciprocal answer. So be very careful in such type of questions. So after next question, okay, it's an assertion reasoning type. Assertion says that with the increase in pressure of an ideal gas, volume falls off more rapidly in an isothermal process in comparison to an adiabatic process. The reason says that in the isothermal process PV is constant, but in adiabatic PV power gamma is constant. Again, we know by theory the reason is absolutely correct. Now let us make the graph. I will make the isothermal process in yellow and make the adiabatic process in green, so that we can see clearly. It's a isothermal. Okay, we are making a PV graph. So this is my drawing of hyperbola. Alright, it looks like it. And now for adiabatic, it is just the same similar graph but more inclined, steeply inclined, like this, something like this. So now here we can see that when you increase the pressure, due to the slopes, the volume of the isothermal does in fact reduce at a quicker rate compared to the adiabatic process. So here we can, from the graph we can see that the assertion is correct, and the reason which we already know is correct. So I'd say, and yeah, why? Due to the PV power gamma, we get the extra, the steeper slope for the adiabatic thing. So the reason also explains the assertion properly. So I'd say option 1 is correct. This is a pretty easy question. I think this was a key change. The original key given by them was wrong, but I think they changed the key. Okay, this is a semiconductor question. What I do every time is I always tend to make errors in the De Morgan's equation. So I just put the options. We just have 4 options, right? I just put them in the thing and I solve it. So let us write our truth table over here: A, B, and Y. So we have to put 0, 0, 0, 0, 1, 1, 0, 1, 1, and let us put it manually and we'll find the values. Alright. Okay, now let us put 0 and 0 in both cases. If we put 0 and 0, A gives us 0 over here, and which we have a 0, and then B0 goes through the NOT gate and becomes a 1. But as this is an AND gate, it is an AND gate, so we need both ones for it to give a 1. Because there's a 0, we'll get an option as 1 in the first gate, and in the second, now for the second thing, we have given 0 in the A gate, it goes through the NOT gate and becomes a 1, and now from the B the 0 comes as it is. Again an AND gate, it doesn't have both 1, so it will give 0 as an output. So it gives 0 as an output here, 0 as an output here. OR gate with 0 0 will give us 0 as an output. So we have 0 0 0. Alright, let me make the truth table in the next one. Okay, I'll clear the previous page for it. So we have A, B and Y. So currently we have gotten 0, 0 and 0. Now let's do the next option. Let me clear all the ink. Alright, now let's put 1 and 0 into the thing. So initially here we are giving 1 and B we are giving it as 0. So here 1 will come as it is, it won't get disrupted, but the 0 goes through the NOT gate and becomes a 1. So we have 1 1 over here, and AND gate with a 1 1 will give us 1 as an output. So we have 1 at this terminal. Now similarly, now let's take the other one. This A goes through the NOT gate and reverses, the 1 becomes 0 and the 0 comes undisrupted, 0, and with 0 and 0 gives us 0 as an output. Now in this OR gate, because we have 0 and 1, what does OR do? If we have anything 1, it's going to give us a positive output. So the AND OR gate is going to give us 1. So we have 1 0 1. So let me mark it in the thing. 1 0 1. Now let us put 1 1. So we gave 1 over here and 1 over here. The 1 comes undisrupted, but this one goes through the NOT gate and becomes 0. Similarly here the 1 goes through the NOT gate and becomes 0, and this one comes as it is. And AND gate, it doesn't have both 1s, so it will give 0 over here. Same thing over here, this AND gate will also give us 0, and OR gate with 0 and 0 will give us 0 as an output. So we have 1 1 0. So we have 1 1 0. Finally let us substitute 0 and 1. 0 and 1. So we have given 0 over here and 1 over here. This comes as it is 0, but the 1 goes through the NOT gate and comes as 0 over here. And now for the second AND gate, this 0 goes through the NOT gate and comes out as 1, and this comes 1 as it is. So 0 0, and we have an AND gate which gives us 0. 1 1 with an AND gate will give us 1. So we got at least 1 over here, so our OR gate is going to give us 1 as an output, and we get 0 1 1. So what do we have here? 0 1 1. So we have, now let us check our options. Oops. 0 1 0. Alright, so what do we have in our answers over here? We have 0 0 0 1 0 1 1 1 0 0 1 1 0 0 0 1 0 1 0 0 1 0 1. So yeah, looking 101. It's a big hassle to go through the other slide. 101 and then 110 011 110 and 011. So option 4 is the correct answer. Alright, let's go to the next question. Okay, this is a theory based question. So they are telling that the difference in the temperature can convert heat to electrical energy. So what do we want here? We want a delta T. We want it to be high so that we have more electrical energy. So in order to harvest the heat, then a material should have. So, and they are telling, okay, so because we want our energy is coming from difference of a temperature, what does have, okay, if two sides of things, it has, assume let's take numbers 20 degrees and 100 degrees this side. Eventually there's a current which is going to flow, a heat current is going to flow, and then it will reach some equilibrium temperature. Both are going to come to the same temperature at some point in time, but we don't want that. We want the difference in temperature. So if we want the difference in temperature, we want less heat transfer. So in order to have less heat transfer, we need to have low thermal conductivity. It's just thermal conductivity. If it's low, we'll have less heat transfer. Okay, low thermal. But once it's converted to electricity, we want to make most of that electricity which is there. So we want it to flow very easily through the wires. So our wires should have low electrical resistance. Okay, wait, sorry, I meant for less heat transfer we need to have low thermal conductivity, and for electrical, okay, low thermal conductivity, and for electricity to flow easily we need to have high electrical conductivity. So it's option 4 is correct. Okay, this is just a units dimensions based question. Young's modulus, what do we know? Young's modulus formula is force by area upon by change in length upon strain, basically. So this thing is dimensionless, strain, because L's are getting cancelled. So we have force by area. What is it? The dimensions are forces mlt minus 2 and areas is L2. So we have Young's modulus has ml minus 1 t minus 2, same as pressure. So this is the match. We know torque is, we know for a fact, okay, torque is just force cross r. So the units are going to be, dimensions will be force times distance, which is mlt minus 2 times L, which is ml2 t minus 2. So torque is going to have ml2 t minus 2. Coefficient of viscosity. What is the unit of coefficient of viscosity? It's Pascal second, right? So the units are going to be basically pressure times into time, nothing but pressure into time. What is it for pressure? ml minus 1 t minus 2, we have derived it here, and into time it's going to give us ml minus 1 t minus 1. So coefficient of viscosity will be ml minus 1 t minus 1, and gravitational constant is going to be this thing. So what is our thing? A2B4 C1 D3. Option 3 is correct. This is a very easy question. Yeah, a very scoring question indeed. Next question. Alright. Sand, okay. Mass proportional to the square root of speed. So we know that dm by dt is proportional to root v. So let's assume dm by dt is equal to some proportionality constant times root v. They are asking the power delivered to the belt to be run at constant speed. Okay, here we need to know the full equation of force. What is force? Force is nothing but dp by dt, change in momentum by change in time. Now what is p? P is nothing but mv. So you have dmv by dt. Now let us differentiate it. Here let us consider both mass and velocity as variable, because you are dropping mass onto the belt, so the mass of it is continuously changing. So what do we get? Let us use the product rule of differentiation. So you get first you differentiate the first function and keep the second as this. So you get dm by dt into v, plus now you differentiate the second function, keep the first one as it is, dv by dt into m. So what is dv by dt? Is nothing but acceleration. So we have force is equal to v dm by dt plus ma. Generally we only learn f is equal to ma. That is because in 99% of the cases the mass of the object which we are observing is constant, but this is the actual equation of force. So but in this case they are telling that the belt is running at a constant speed, so our acceleration is going to become 0, so this term is going to become 0. So we will use the definition of force as v into dm by dt, and they are asking us the power required to run the belt. What is power? Power is nothing but force into velocity, and we have force as v dm by dt. So we get force into velocity, which is power, is equal to v square into dm by dt. I just multiplied v over here. So v square into dm by dt. What do we have in the question? We know that dm by dt is proportional to the root of the velocity. So finally I am going to put k root v instead of this dm by dt. So finally we get power is equal to k into v square into root v. Root v is just v power 1 by 2. So you have k into v power 2 into v power 1 by 2, which is equal to k into v power 5 by 2. Now let us square on both sides. So squaring on both sides we get p square is equal to k square into v power 5. So k is just the proportionality constant, so we get p square is proportional to v power 5, and option 3 is correct. On to the next question. Okay, this is a good question. uh, we should know, how particles behave among mutual gravitation fields for this. If they are placed, okay, I will tell you a thing. If they are placed on an equilateral triangle, the meeting point is the centroid. If they are placed on the vertices of a square, they are going to meet at the center of the square. Similarly, they are going to meet at the center of that geometrical shape. This is a fact which we need to know. We can also derive it, but it's a very lengthy process. So yeah, it's just better to know. So we know that all this, they are attracted by only their gravitational forces. So eventually they are going to meet at the centroid. How? Like particle A, they are going to follow a spiral path like this, some weird path they are going to follow, and they are going to meet at the centroid of the triangle. And they have given a side of the triangle is A, and they told it's an equilateral triangle in free space. So we can assume that no other objects are there apart from these three. And they are asking us to find the angular momentum of the system about the point of collision. The point of collision is the centroid over here. So let us do that. Okay, centroid. What are the coordinates of centroid? We know that centroid divides the median in ratio of 2:1. So what's the median's length? So if we take the, okay, this is the median, and our centroid is over here. It's dividing it into 2:1 ratio. This is 60 degrees. So just take the vertical component of this side AB, and we get the median length is equal to A sine 60, which is equal to A root 3 by 2. Okay, it's just getting a bit messy. I'll just clear. Okay, I'll make it here after some time. Okay, so we get A root 3 by 2 as the centroid, as the median's length. Now this divides it in the ratio of 2:1. So this part is just 1/3 of the median, and this part is 2/3 of the median. So the median is A root 3 by 2, and then 1/3 of it is going to be A by 2 root 3. This root 3 will cancel and you get root 3, basically like that. Okay, so I'll make the diagram properly. We have it like this, and centroid is here, and we have this length as A by 2 root 3. This is perpendicular because equilateral triangle properties. Similarly, again this centroid, even this is a median over here, so this is also going to be 1/3 the median, A by 2 root 3. Similarly, even this will be, my drawing is not accurately to scale, but you get the idea, A by 2 root 3. And then now let us take only this side into consideration once for ease of explanation. So you have you have the particle moving with a velocity v0, and then from the point, the perpendicular distance of the line is A by 2 root 3. So we know that angular momentum is given by mass of the object into velocity times the perpendicular distance of the line from a point, in this case. So we get that L of one particle is given by mass into v0 into r is nothing but perpendicular distance, that is A by 2 root 3. A by 2 root 3. So we get that the angular momentum of one particle is mv0a by 2 root 3. But however, we have three particles, one at each side, one at each vertex. So we can and all are traveling in the similar manner. So we can just multiply the angular momentum of 1 by 3, one of it by 3, and we'll get the whole momentum. So we'll get the angular momentum of the system as 3 into mv0a by 2 root 3, which is root 3 by 2 mv0a. Now let us go to the options. Option 3 is the correct answer. Next question. Okay, they have asked, I think, 3 ray optics questions, and yeah, so the chapter weightage was a bit off. Like January, every session was like that. Okay, convex made of glass has 24 centimeters focal length in the air. When it is totally immersed in water, its focal length changes to. Okay, Here again we have to use the length maker's formula. So let me take focal length in air as FA, and focal length in water I'll take it as FW. So we have, let us apply the length maker formula in the air. And air refractive index of air is always taken as 1 if they don't say anything. So 1 by FA is equal to 1.5 mu. So what's the lens maker's formula? 1 by F is equal to mu of the lens by refractive index of the medium minus 1 times 1 by R1 minus 1 by R2. So 1 by FA is given by refractive index of the material 1.5 divided by 1, which is index of the air, minus 1 by 1 by R1 minus 1 by R2. And what is it in the water? So 1 by focal length in water is given by refractive index of the material by refractive index of water. This is the thing where this is where the change will be, minus 1 by 1 by R1 minus 1 by R2. Now let us divide. This is equation 1, this is equation 2. Let us divide both of them. So you get FW by FA is equal to 1.5 by 1.5 minus 1 by 1.5 by 1.33 minus 1. And these two things, the radii of curvature will be the same in the water or the air. So these two terms are going to get cancelled. So this is what we are going to be left with. So we'll get focal length in water is equal to focal length in air times 1.5 minus 1 is 0.5, and here okay, I'll take 1.5 as 3 by 2 and 1.33 is 4 by 3 because I see good numbers over here. Divide by 4 by 3 is multiplying with 3 by 4 minus 1. So I get focal length in water is equal to, okay, they have also given focal length of air in air is 24 by 1 by 2 and divided by, so this is FA into 0.5 by this is 9 by 8 minus 1, 9 by 8 minus 1, so denominator is 1 by 8, 1 by 2 by 1 by 8. So finally we are left with focal length in water is 24 into 4, which is 96 centimeters. So option 2 is correct. It's a bit laggy. Yes. Okay, this is again a theoretical question. Experiment with photoelectric effect in the stopping potential. Let us write the equation for stopping potential. What do you have? Electric charge into stopping potential is equal to frequency of the incident light, energy of the incident light minus the work function. So let's divide with electric charge on both sides. So we get stopping potential is equal to, I'll take V0 as stopping potential, h mu by E minus work function by E. Okay, now let us see the options. Okay, the stopping potential increases with intensity of incident light. Now let us look at the equation of here. The stopping potential just depends on the frequency of the light and the work function of the material. It is independent of the intensity. So option 1 is wrong. Let us see. Decreases with the decreases with increase in intensity. Again, as we have checked in option 1, it is completely independent of the intensity. So option 2 is also wrong. And now they are telling increases with the wavelength of the light. Okay, for clarification I'll just write the frequency is equal to c by lambda. C is speed of light, lambda is wavelength. So we get stopping potential is equal to hc by E lambda minus work function by electric charge. Now they are telling increase in wavelength. Now if we increase this wavelength, this whole term is going to decrease, and then our stopping potential is also going to decrease because this thing is going to be constant. So we get option 3 is also wrong. And now they are telling the stopping potential is 1 by E times the maximum kinetic energy of emitted electrons. Okay, what is the maximum kinetic energy of the emitted electrons? It is just the energy of the radiation minus the work function, and then if you multiply it with 1 by E, we are getting the stopping potential as we have derived above. So I'd say option 4 is correct. Next question. Okay, a capacitor of 6 microfarad is charged to 5 volts using a 5 volt battery. The battery is removed and another capacitor is added in the same battery in the same place. Okay, that capacitance is 12 microfarad. When the switch is closed, the charge flows between the capacitors until an equilibrium condition is reached, and they are asking us the equilibrium charges. Okay, this is a pretty easy question. So initially you are charging the 6 microfarad with a 5 volt battery. So you have 6 microfarad and 5 volts. Let us find the charge on the charge initially. So what do we know? We know that charge on a capacitor is given by capacitance times the voltage across it. So here it's going to be capacitance is 6 microfarad into 5 volts. So my charge on the capacitor I get is 30 microcoulombs. Alright, now I remove the battery. Once I remove the battery, it's just going to be a capacitor with 30 microcoulombs of charge in it on each plate with opposite signs. And now 6 microfarad, I connect a 12 microfarad capacitor to this. So what happens? Some charge is going to come here, charge redistribution is going to take place. So let us see what we can do here. So this is our diagram. This is the 6 microfarad and this is the 12 one. Some charge is going to move from here to the 12 one. So I'll assume the final charges as some 30 minus Q, and whatever the Q this loses, this 12 capacitor gains because conservation of charge. Okay, now with these things, the potential difference across any two capacitors in parallel will be the same. So what we know that Q is equal to CV, and we get potential difference is equal to Q by C. Now let us equate the potential differences. This is 6 microfarad, this is 12 microfarad. So potential difference across the 6 microfarad is going to be charge on it, which is Q by C, which charge on it is 30 minus Q, and capacitance is 6 micro, which is 6 into 10 power minus 6 farad. This potential difference will equal to the potential difference across the 12 microfarad one. So the charge on this is Q divided by 12 microfarad, 12 into 10 power minus 6. So 10 power minus 6 is cancelled. So we are finally left with, I'm multiplying the 6 over here, 30 minus Q is equal to 6Q. What? There's a 12 also over here. And so this becomes 6 once and 6 twice. So I get 60 minus 2Q is equal to Q. So I get 3Q is equal to 60. So I get Q is equal to 20 microcoulombs. So on the 6 microfarad, our charge is 30 minus Q, and we got Q as 20. So which is going to be 10 microcoulombs on the 6 one. On the 12 microfarad one, we are going to have Q coulombs, which is nothing but 20 microcoulombs. So let us see the question. Q1, okay. On C1 we had 10, and on C1 we had 10, and C2 we had 20. So Q1 is 10 and Q2 is 20. This is the correct answer. And also in this question, we know that charge is conserved. Initially the charge is 30 microcoulombs. So right off the bat you can eliminate option 2 and option 3, because here the charge is summing up to 45, which is not possible. This breaks the laws of physics. So these two you can eliminate right off the bat. So it's either this or this, which you can solve. Right, next question. Okay, this is just plane magnetic wave proceeds along the plus x direction in free space. So we have, I'll assume the direction of propagation as k cap. Okay, sorry, not k cap, we'll get confused with it. I'll assume it as p cap, propagation. So the p cap is along I cap. Components of electric field E and B are, okay, we know that direction of propagation is given by electric field direction cross magnetic field direction. So now let us use our right hand thumb rule. Okay, you can't see me doing it right over here, but let us, okay, so let us check for option A. As you are crossing vectors, we know that P cap is perpendicular to E cap, and all are perpendicular to each other because it's a plane electromagnetic wave. All are perpendicular to each other, and our P cap, so P cap is equal to I cap, so we'll have a Px. So none of your E cannot be X, E is X, cannot be X, or B also cannot be X. So we can eliminate option 1 and we can eliminate option 2. Okay, now let's option 4. Let's check for option 2. So E cross B. Now let us apply the right hand rule over here. So I'll put my hand along the Y direction and curl it towards the Z direction. So now we can see that our thumb is pointing towards the X direction. So these are the correct vectors. So you'll have an electric field along the Y component, and you'll have a magnetic field along the Z component, along the Z direction. So these are the waves. So option 2 is the correct answer. So next question. Okay, Newton's law of cooling. This is deleted, but they still asked it. As they asked it, we are going to solve it. Okay, fine. So what does it say? We are not going to use the differential form of it. We will just use the direct formula. So Newton's law of cooling says that, I'll use theta for temperature because T is for time. We might get confused. Theta is for temp and T is for small t is for time. So according to Newton's law of cooling, we know that delta theta by delta T is proportional to the average temperature theta 1 plus theta 2 by 2 minus the theta naught is the environment temperature. So let me assume it cooled from 90 to 80. So delta theta is going to be 10, and they told it in T minutes. 10 by T is equal to some constant of proportionality times theta 1 plus theta 2 by 2. So basically average of 80 and 90, which is 85, minus the environment temperature. The room temperature is 20 degrees over here. Okay, that line was bad. So we get 10 by T is equal to 65 K. Let me divide with 5 on both sides. So I get 2 by T is equal to 13 K. Eventually I get K is equal to 2 by 13 and T is in denominator. Okay, now they are asking me how long it will take to cool from 80 to 60. Let us apply the same thing again. Delta theta is 20. Now the new time, let me assume it as A, my wish, any variable, 20, and it will take A time for it, is equal to K. The constant of proportionality is 2 by 13T. We have solved for it in the previous equation. 2 by 13T times average of both the temperatures, which is 50, minus the surrounding temperature. Surrounding temperature is 20. Oh wait, 60 and 80, it's not 50, sorry, my bad, it's 70. Minus 20. So we get 20 by A is equal to 2 by 13T into 50. So I'll cancel things out. 2 ones are 2 tens are, and 10 ones are 10 fives are. So finally what do I get? I get, rearranging it, okay, I get 1 by A, I'll write a step, 5 by 13T, and eventually I get A is equal to 13T by 5. So option D is correct. This is a deleted question, they shouldn't be asking this, but yeah, we'll solve it anyway. It's a very easy topic though, it's a very scoring topic. Okay, next question. Okay, this is a bit lengthy question, a lot of calculations involved. Alright, but we'll solve it anyway. The formula which we are going to use in this question is mu2 by image distance minus mu1 by object distance is equal to mu2 minus mu1 by radius of curvature of the surface. Okay, and they are telling that the refractive index here is 3 by 2. I gave 1.5, 3 by 2, and 3 by 2 here, and here it's 1 and 1 air. And then they are asking, we kept an object here, there will be an image formed due to glass B, and then there will be an image formed due to glass A, and then they are asking us to find a separation between the images. Okay, first let us approach glass B. So they gave us this distance as r by 2, so even this will be r by 2 as it's the midpoint, r by 2, OP is r by 2. So you have glass B over here, radius of curvature is r, refractive index is 3 by 2, and you placed an object at a distance of r by 2, and refraction is happening about this. So I'll take this as the center of curvature. I'll mark it in another color. This is the center of curvature. Again, as I have told you previously, which direction do you need to go from here in order to reach the center of the circle? It's this way, right? So it is negative. Again, I'm taking this as my coordinate system. So I will take the radius of curvature of this as negative according to sign convention. So now let me apply the formula. So I get mu2, which is the refractive index of the glass, by V, I'll take it as V, minus, compared to here, our object is at a negative distance. We are traveling along the negative x-axis. Our x coordinate of our object is negative. So we take the sign convention here, minus mu1 is just 1, by u is r by 2, minus r by 2, strictly speaking, is equal to mu2 minus mu1, 1 by 3 by 2 minus 1, which is 1 by 2. Mu2 minus mu1 is 1 by 2, and radius of curvature is again what? Minus r, because it's curving in this way. So minus r. So you get 3 by 2v is equal to, this thing is going to become plus eventually, minus minus, so I'll just cut out the minus over here, and I'll transpose it to this side. Minus 1 by 2r minus 2 by r. So you get 3 by 2v is equal to minus 1 by 2 minus 2, which is minus 5 by 2, minus 5 by 2r. I'll cut the 2 and 2, 2 and 2 cancel. So we finally get v is equal to minus 0.6r, or 3 by 5 or 0.6. So an image, so v due to glass B is equal to minus 0.6r. Let me just highlight this, we'll use it in the future. Okay, now let us apply it for the glass A. So we know that they have given us like this in the question, but I'm going to reverse it. We just want the distances, so I'll assume my glass to be like this again, 3 by 2, but now the image distance is a bit far, 3r by 2. Again the curvature is minus r because everything is curved the same way. I'll directly apply the formula. Mu2 is the glass, mu2 is 3 by 2, mu1 is 1. So mu2 by v, 3 by 2v, minus of mu1 is 1 by 3r by 2, 3r by 2 is equal to mu2 minus mu1, which is 1 by 2 by radius of curvature is minus r. Now again we get 3 by 2v is equal to minus 1 by 2r minus 2 by 3r. So if I take minus 1 by r common, I have 1 by 2 plus 2 by 3, which is nothing but oh my god, why am I doing this? 1 by 2 plus 2 by 3, 3 plus 4 by 6 is 7 by 6. Yeah, so we have 3 by 2v is equal to minus 7 by 6r. So you get 2v is equal to minus 18r by 7. So you get v is equal to minus 9r by 7. Okay, now let me go to the actual drawing. I'll clear up. We remember this 0.6r. So it's like this. This image is forming at 9 by 7 r. This image is forming at 3 by 5 r. Okay, 3 by 5 r, and let us assume the distance between them as d. But however, we know that even this length is r, the whole distance between the two center of curvatures is r, no, 2r. So let us apply the condition. So you get 9 by 7r plus d plus 3r by 5 is equal to 2r. So you get d is equal to 2r minus 9r by 7 minus 3r by 5. LCM is 7, 5 and 35. So 35. For 2 it's going to be 70r. Oh, that's a lot. And for 9 it's going to be multiplying with 5 minus 45r. 45. And for 3 it's going to be multiplied by 9, 18. So finally we are going to be left with 4r by 35. What is 4 by 35? Again we have to divide it. Then 4 by 35 is a bit more than 0.1. So it's not this, it's not this. So it's either 3 or 4. Now let me divide it. Okay, NTA makes me divide these things also now. So 4 by 35 is 4 and 35, 0.150, 1 minus 35 is 15, 0, 4. So we get 0.114 as the answer. So this is not 18 actually, sorry, my bad, 21. Okay. Oh, again we have a units thing. So okay, magnetic induction is just nothing but magnetic field, and that is Gauss. This is just theory based. And magnetic flux is Weber. And what is magnetic moment? Magnetic moment is nothing but magnetic moment of a solenoid is given by number of turns into current into area of it. So number of turns doesn't have any unit. Current is ampere and area is meter square. So magnetic moment has ampere meter square, and then magnetic intensity has ampere per meter. So now matching it, we have A3, B4, A3, B4, C2 and D1. So option 4 is correct. This is a very scoring question, but in the actual exam they have misprinted this, I think, as ampere times meter. They have misprinted it, so this question was dropped in the exam. But this is how you do this question. It's a very scoring question, but yeah, they have dropped it. Okay. Point charge causes an electric flux of minus 2 into 10 power 4 Newton meters per coulomb on a Gaussian surface of 8 centimeter radius. And then they are asking us the value for the point charge. We know that electric flux through a closed surface, Gaussian surface, is given by charge enclosed by the surface divided by epsilon naught. I don't know. We honestly don't need this thing. We don't need the 8 centimeter radius, but okay. So they have given the flux as minus 2 into 10 power 4 and is equal to q by, and epsilon naught as 8.85 into 10 power minus 12. As it's causing a negative flux, we know that our charge must be negative. So option 1 and option 2 are immediately wrong. We can eliminate them. So we get q is equal to 2 into 8.85 into 10 power minus 12 plus 4 is minus 8. So this is going to be 17.7 minus, everything with a minus, into 10 power minus 8, which is option 4 is correct. I think why they have given this radius is so that it's a point charge and the radius is this thing. So people tend to find the area 4 pi r square, and then they multiply it with the electric field k q by r square, and it's all a big mess, but you eventually end up with the same thing. So this, if you use the radius, you have to do a long thing. I'll tell you how it equals the same thing with the radius. So you have 4 pi and r square are getting cancelled into k into q. What is k? K is nothing but 1 by 4 pi epsilon naught. So you have 4 pi q by 4 pi epsilon naught So you just cancel and you get the same thing which you have gotten by the Gauss law. So this thing is just to make you calculate everything, the r square and the field and all. This is a time waster question. You should do it in the smart way. Next question. Okay, electric dipole is placed at an distance of 2 centimeters from an infinite plane having charge density as positive. Because it's a positive charge density, our electric field is going to be in this way, and it's going to be uniform everywhere. Because it's an infinite sheet, our electric field is going to be sigma by 2 epsilon naught everywhere. So now what is this? It's just a nothing. It's nothing but a dipole, q and minus q, placed in an external electric field. So, and here theta, the angle made by the electric field and the dipole moment, is equal to 0, and we know that torque is given by P cross E. So the magnitude of torque is going to be Pe sin theta. However, here theta is equal to 0, therefore this term will become 0. So we have torque is 0. And then what's the potential energy of a dipole in an electric field? So potential is nothing but minus P dot E. So it is going to be minus Pe cos theta. As theta is 0 here, theta is equal to 0, it implies cos theta is equal to 1. So our potential energy is going to be minus Pe. It's the least, it cannot go anymore because our cos is at the limiting value over here. So this is the least, as it is the negative sign, it is the least value it can be. So we get potential energy is minimum and the torque is 0. So option 4 is correct. Okay, next question. We have come to integer based questions. Okay, magnetic field inside a solenoid of radius 10 centimeters is this thing, and if a solenoid carries a current of 0.29, they are asking the length of the solenoid in centimeters. Always be careful about the units, especially in integer type, because it can be anything. The options aren't there to guide us. So yeah, make sure it's centimeters. Okay, so alright, what's the field inside a solenoid? Mu naught into number of turns per unit length, total number of turns, I'll take it as n, number of turns by length of the solenoid into current is equal to field. They have given the field as 2.9 into 10 power minus 4 is equal to mu naught is nothing but 4 pi into 10 power minus 7, if they haven't given anything, so we'll assume it as this, into number of turns is 200, 2 into 10 square, current is 0.29, which is 2.9 into 10 power minus 1, and whole thing by the length of the solenoid. So now I'm going to cancel some stuff. 2.9 and 2.9 are cancelled, and so finally I end up with, okay, L is equal to 8 pi 4 pi into 2 10 power 2 10 power minus 1 by 10 power minus 4. It comes, the 10 power minus 4 comes from here. So you get, this is 8 pi, not 8 Tesla, it looks like that. Okay, length of the solenoid is equal to 8 pi into 10 power minus 1 into 10 power 4, 8 pi into 10 square. So what is this? We already have a 10 square over here, so we have automatically converted into meters. So it's just 8 pi centimeters. This 10 square is taking care of the meters for us. So we have 8 pi centimeters, so the answer is 8. Okay, parallel plate capacitor consisting of two circular plates of radius 10 centimeters is being charged by a constant current of 0.15 amps. Rate of change of potential difference is this much, and then they're asking the integer value of the distance between the plates in micrometers. Okay, so what do we have? We have that Q is equal to CV, our general capacitor equations. Now let us differentiate with time on both sides. So we have dq by dt is equal to C into dV by dt. Here the capacitance is constant with time. It's not changing with time, so we can assume it as a constant and just differentiate the voltage. So but what is dq by dt? Dq by dt is nothing but the current. So we have I is equal to C dV by dt. What's the now what's the capacitance of a parallel plate capacitor? So we know that it is epsilon naught area by distance between them. So what do we have finally? Current is equal to epsilon naught area by distance between the plates into rate of change of potential difference. Now let us plug in the values. Okay, they gave us good numbers. They asked us to take epsilon naught as 9 into 10 power minus 12. Okay, nice. So current is 0.15. I'll write it as 1.5 into 10 power minus 1. I have this habit of writing everything in scientific notation. Is equal to epsilon naught is 9 into 10 power minus 12. Area is pi r square. Radius is 10 centimeters. So pi is 22 by 7. And r square is, radius is 10 power minus 1 meter. So r square will be 10 power minus 2. So 10 power minus 2 into rate of change of potential difference is 7 into 10 power 8. So I'll cancel this 7 and this 7. So we have again 1.51s and 1.56s by D. I forgot the D. So D is equal to 6 into 22 into 10 power minus 12 minus 2 plus 8. So 10 power minus 12 minus 2 is minus 14 plus 8 is minus 6 divided by 10 power, oh my god, okay, 10 power minus 1. So we have 132 into 10 power minus 5, which is nothing but 1320 into 10 power minus 6. Minus 6 is there, it will take care of the micrometers. So we have 1320 as the answer to this question. Alright. Next question is, two planets A and B are orbiting a common star with circular orbits of radius Ra and Rb with Rb as 2Ra. Planet B is 4 root 2 times more massive than planet A, and they are asking the ratio of angular momentum. Okay, so let me make a list of what all planet A has and what planet B has. So let us assume planet A has mass m, radius r, radius and mass, yeah, that's all we have at the moment. And they told it's 4 root 2 times more massive, so this mass is going to be 4 root 2 m, and they gave Rb is 2Ra and 2r. Alright, now for what else do we need for angular momentum? We need the velocity of it. But what do we know? According to Kepler's laws of orbits, we know that t square is proportional to r cube. That's it. And so square rooting, we have t is proportional to r power 3 by 2. And then what is t? T is nothing but circumference of the path, circular orbit, so it's 2 pi r. 2 pi r by velocity is equal to r root 3 by 2. So we have v is proportional to 1 by root r. Alright, so here let me assume v, because it is 2r, is going to be v by root 2 in this case. Check the proportionality, it is going to cancel, it's going to match. Right, is it matching? V is proportional to 1 by root r. Alright, let me check if I did anything. Okay, t square is proportional to r cube, t is proportional to r power 3 by 2. So t is nothing but 2 pi r by velocity is proportional to r power 3 by 2. V is proportional to r power minus 1 by 2. So v is proportional to 1 by root r. Alright, finally, okay, so we have this and we have this. So let us just calculate. Angular momentum of A is going to be mvr, nicely. Angular momentum of B is going to be 4 root 2m v by root 2 into 2r. So which is root 2 and root 2 are going to cancel, nice. So we are left with 8 mvr is equal to lb. So taking the ratio, we get LB by LA is equal to 8 MVR by MVR, which is 8. So answer to this question is 8. People generally panic looking at these questions, but it's such a simple question. So this is a very scoring question again. Okay, 49. Okay, two cars are moving in the same direction. Acceleration of P increases linearly with time, whereas Q moves with a constant acceleration. Both cars cross each other at time t is equal to 0 for the first time. Maximum number of crossing is okay. They are telling that for car P, acceleration is proportional to time. So let me take A is equal to some kt. Okay, and now let me integrate on both sides. So integration of acceleration with respect to time will give me velocity is equal to k t square by 2 plus c, some constant. And again let me integrate on both sides. This is for P, car P. Now integrating okay, as they're moving linearly in the same direction, I'll assume it as x. So integrating velocity with time, we get x is equal to kt cube by 6 plus ct. Here I'm not adding a constant. You know why? Because I'll assume both of them start at the origin initially and then they move. So because it has to satisfy the origin at t is equal to 0, I want x to be 0. So I'm not adding a constant. I won't add the constant for the position even in car Q's case. But for car Q they told acceleration is equal to constant. I'll take A as some what variable should I take? A as R. Just in. Okay, integrating again, I get V is equal to RT plus C. Here R is just a constant. Okay, it's not the radius or something. Again integrating, I get X is equal to RT square by 2 plus CT. Again I'm not adding the constant over here. And in order for them to cross, the x value of this must be equal to x value of this. So we get equating both of them, I get kt cube by 6 plus ct is equal to RT square by 2 plus, okay, I won't take C here, C we have already used, I'll take it as S. Oh, S is again displacement. Okay, dt is not the integration dt. Oh my god, again the variables. Okay, I'll take it as E. So this will be ET plus ET. So rearranging the terms, we get plus RT square by 2 plus CT minus ET is equal to 0. Here we can see that it's a cubic equation in T. So the maximum number of possible routes it's going to have is 3. So the maximum possible crossings are 3 crossings. That's it. Right. So okay, I think this is the last question. A physical quantity Q is related like this, and then they're asking us to find the percentage error in Q, and they have given all the quantities with their errors. Now let us find the percentage error in A. Percentage error is, so A is 60 plus or minus 3. So percentage error is going to be the error uncertainty by the main value into 100. So percentage error in A is nothing but 3 ones, 3 20s, which is 5. So A has 5% error. Now let me do it for option B. For option B it is 0.1 by 20 into 100, which is 0.1 for B, for quantity B, 0.1 into 5, 0.5. So B has 0.5% error. Let's check for C. C is 0.2 by 40 into 100. 22s, 25s. So again C also has 0.5% error. Now let us check it for D. D is 0.1 by 50 into 100. So once 52 is equal to 0.2%. Okay, these are the respective percentage errors in each of the quantities, and they told Q is equal to A B power 4 by CD. So what's the error in Q in going to be? As it's B power 4, only the error in B is going to get multiplied by 4. Everything else will remain the same and get added up. So it's going to be 5 plus 4 times 0.5 plus 0.5 plus 0.2. So we get the error as 7.7%. But what have they given in the question? They told our error is x by 1000. So 7.7 is equal to x by 1000. From here we get x is equal to 7700. Even in this question, initially the key was given as 77 for some reason, but it was changed to 7700. So yeah, I think empty slides. This is it for this session. So I hope you have understood how to do all these questions. If you have any doubts, please feel free to comment. Alright, I'll be back with the next video. Thank you.